right, we're back. Hello, Piotr. Great to see you, man.
Hi, Carol. How's it going? Thank you for the
Yeah,
invitation.
I'm glad that you called in and that we can start. So, guys, for those who don't know Piotr, Piotr is a cloud and across architecture-oriented tech lead. He's also a co-founder and CEO of a startup. And I think in your career, Piotr, you designated and validated and even deployed tons of data centers, service provider, and enterprise networks across Europe. But I think you will tell us about yourself even more. Once again, I'm happy that you are here. I'm happy that you're presenting security in terms of the serverless, so the floor is yours.
Yes, thank you, Carol. And let's kick off the session and let's get started. Do you see right now my screen?
You're good to go.
Do you see my screen? Can you please confirm?
Not right now.
Not right now. Okay.
Yes, yes,
okay.
You're good to go.
Okay. So right now I am a cloud solutions architect at Palo Alto Networks, and the main topics I'm covering right now are related around security, not only public cloud but also cloud native applications, so they can be deployed anywhere. So I would like to quickly discuss threats and how you can prevent some examples of the attacks on the serverless apps. We focus on Lambda functions. So, for example, AWS shared responsibility model includes 2 layers. And apparently, you may think that those 2 layers are disjoint. But in fact, if we have a look on the runtime or IAM, those responsibilities are interleaving. It means that AWS, for example, can take care of how IAM is protected overall, how is it provisioned, how is it deterministic, how it behaves and integrates with other tools. But it's your responsibility to write down proper IAM policies, roles, and make sure that you don't assign over permissive rules and you don't assign, like inside CI pipelines, permissions to someone who can create rules on his or her own account. So there are some couple of challenges in this model. And you may also think that with serverless, you don't have nothing to do with networking and nothing to do, or almost completely nothing to do with networking security. In fact, it's the opposite. There are a lot of references to TCP/IP stacks. Functions are everywhere. APIs and sockets are not only used for web applications. During Alex's session, he mentioned very important message. Serverless, it's not all about web applications. It can be related to any application, actually. And this is the same if you have a look from the security perspective. You should treat serverless as a normal application. You need to cover, you need to secure. There are common mistakes with serverless, like keeping secrets or hard coding variables in the code. And I wouldn't like to cover, because of the time frame, every aspect of the security. I would like to focus on web attacks and how Lambda function is isolated, in fact, in AWS environment. So if you have a look on the serverless architecture, there are a lot of different components. And apart from the Lambda functions with the code, you can use API gateway, which is protected with AWS WAF, for example, or some cloud-based web application firewall. You can have also additional services. And again, you may think that if you run AWS WAF, it's enough it's enough to protect against layer 7 attacks and against API attacks. But the truth is a bit different, because the vector of the attack is nowadays not only from the internet side of the infrastructure, but also from the inside. Why? Because someone is creating the code. There are some repositories, there are some infections. The malware can be injected at any stage of the producing your code. And that's the case of SolarWinds, where the backdoor was injected through injecting 8,000 lines of code. It wasn't just 2 lines, 10 lines. That was there were 8,000 lines of the code which were injected, where the process detected compilation of the Orion library component. Additional fact is that you can have a chain of Lambda functions, and to protect that, you need to cover east-west protection, or also protect your communication to different services which are enabled in the public cloud. So I would like to right now jump to a small demo where I will be showing you 2 functions. One Lambda function just to show you how the connectivity can be established to external world, and the second one on the right-hand side to present layer 7 attacks. So for that purpose, let's start from the example and the consideration how Lambda is truly isolated. If, let's say, I will create a new function, I will call this function just Lambda, and I will leave all other settings as it is by default. Let's say I will choose Node.js because I will paste Node.js function, create the function. And here is the question: can I connect to the internet repositories or any resource with such default connectivity? I mean default settings. Look, I don't have any triggers. I don't have connectivity to API gateway. I don't have any connectivity to other services. And what's more in the configuration, there is no VPC configuration at all. Just blank configuration, nothing more. In the code, I will insert the code which is establishing the HTTPS session, but on the port SSH. So the question is, can I by default connect to the external world? And the answer is unfortunately yes. Let's test it. Let's create the test. And the data, because the port is not accepting this communication. All right, the test is prepared. On the host itself, I will be running TCP dump on port 22. And let's try and do the test. Function invoke error, of course, because there is no open port, but in fact, there is an open communication from EC2 instance, which is hosting Firecracker micro VM, and the Lambda function itself. And we can see that there is a communication to SSH port, actually. So if your code is somehow infected, and this is quite easy today to be infected through repositories, through the code, through Stack Overflow, through different libraries, you can have an exfiltration of the data. You can have a communication to the external command and control center server on any port, not just through the API and not just through web ports like HTTP, HTTPS. That's the very important key. And you need to look at your Lambda functions and serverless architecture like a normal workload infrastructure. You don't manage EC2 instances or Firecracker instances, but in fact, you need to take care and you need to think that your network layer is right now a bit higher. It's hosted, but it's still there. What we can do with that, we can deploy, we can of course isolate the Lambda. So if you assign this Lambda to the specific VPC, and this VPC will not have the internet gateway or the external connectivity will be blocked, of course Lambda will be blocked as well. But what if some Lambdas has to communicate through API gateway? Then of course such a communication has to be established. So how can you control? You can use additional wrapper which is running in the runtime, and this can make sure this system can guarantee that all the instructions done in the runtime, because the code of the Lambda is executed in the runtime of the Firecracker, but you can inspect what is done there, and you can block specific communication. So let me quickly deploy additional protection. This can be done automatically through API. I'm detecting all the Lambdas, and I'm applying the Defender. The Defender will be showing as an additional layer component. At this moment, layer numbers, the number of layers is 0. Okay, Defender status is increasing, so I'm installing protection for all Lambdas in my specific environment where the API keys are having the privileges to write, to read data from. But I did also inspection of all my Lambdas meantime, and this is the view. If you have the proper tools, you can also have a look which Lambda is protected, which not. And you can scan all the Lambdas in terms of vulnerabilities and in terms of compliance, good practices, rules. So for example, this test-free Lambda is not protected at all. If we have a look on the, let's say, specific communication or let's pick up any function, we can see what are the privileges, and we can see what are the current vulnerabilities and compliance checks. So at this moment, there is one highest severity vulnerability detected. And what you can do with that, you can simply use the package or library or a module which is not infected. It's not vulnerable. At the same time, you can comply with the compliance rules to, for example, do not store the private keys or turn off unused service APIs. Once the Defender is deployed, let me check if it's deployed. Yes, it's deployed. The handler is changed, and you can write down the policies just to block the connectivity. So if I go to serverless policy, I will do actions enable. In this enable policy, I can block not only processes, I can allow just ls, for example, but I can block also connectivity and DNS requests. So at this moment, I'm blocking any IP connectivity apart from 1.1.1.1. And if I do save, after a couple of seconds, the policy should kicks in and it should work. Let me check. If not, we will wait a bit longer. But meantime, let me find out. There is no new connectivity, as you can see. I will start the test again. No new connectivity. Just to confirm that it's really not, it's really blocked. We can go to the monitoring service, serverless audit, and we can see just the recent activities. And we can confirm that, in fact, 20th of October, 3:25, the connectivity to the external node was prevented. So in such a way, you can guarantee that such a connectivity is really blocked from inside of your environment to the external world. And additional example, which I would like to show, is related to SQL injection and code injection. So there is a vulnerable Lambda function, which I'm referring to through curl. And right now, it's even blocked already because I applied. Let me check. So this is function called my SQL. So essentially what Lambda is doing, Lambda is connecting to RDS database, and there's the API gateway which I'm using to connect to this Lambda function. This Lambda function is also protected. And let me check. Monitor logs. There is internal server error. Yeah, this function is right now using the connection. The connection is correct. Okay, let me find out the last thing, which I will check, because this function should be right now responsive. All right, let's do this differently. As we have this function, let me check the last thing. Okay, events. Okay, so we can see that this the invocation of this Lambda has been done. So that there are two invocations of Lambda, the first example, and the Python invocation, which is done later. 3.8, okay. And let's check what is here. Okay. Why this Lambda does not work? Because this Lambda is connecting to the database through using DNS. It can be a good, it's not necessarily good practice, of course, because if we place our database in the same VPC, of course, we don't need to use public DNS. But in this case, the public VPC is, the public DNS is used. So this is prevented because of my rule, which I just applied. So let me quickly turn off this. I could add RDS here, but what I can do, I can also change to alert. All right, let's change it. I think within a couple of seconds it should kick in this policy, and let's have a look. Not yet. Not yet. Okay, so meantime, just a couple of conclusions, and I will show you at the end of the presentation just the final thing, which can be also the threat to your Lambda functions. I mean layer 7 attacks. So such a layer 7 attack can expose not only data in the database, but also it can expose your metadata, which is hosted on the same EC2 and Firecracker instance where the Lambda function is running. Once you get the access to the Lambda, once you get the access to the specific Lambda with privileges, so every Lambda has its own privileges. If those permissions are over-permissive, so this Lambda specifically opt-grep analyzes get result file has three permissions. If those permissions are over permissive, so there are possible actions to create to delete, for example, tables in DynamoDB, or if your secret keys are embedded, you can use those data to elevate your privileges. Elevating means you can gain additional privileges based on the basic metadata which are stored for this function. And these basic metadata can be exposed through layer 7 attacks. And layer 7 attacks can be done, not yet still. So just last step, what I will do, I will apply defense. Just to show you, I did this attack just before the session. SQL injection, and just to confirm, you can also block SQL injection, command injection. You can block layer 7 and API attacks also through this method of using additional layer in your Lambda functions. As you could see, you can deploy such a prevention very easily across all your environment, and simply make sure that this security parameter is established. If my policy is running correctly, this code injection could expose from AWS setup the listing of my whole Lambda function. It's still not there. Okay, let's leave it maybe for another occasion. But anyway, thank you. If you have any questions, please shoot out to me, and I'm willing to answer. Thank you.
All right, Piotr, thank you very much. Thank you very much for your session and the time you spent preparing that. I think we've got no more time remaining for the questions, so I'll put the question on the chat to let you go, and then we'll move on to the next speaker. So Piotr, it was great to see you. Thank you very much, and take care, man.
Thank you. Take care. Good luck. Bye-bye.